Actually, when I started doing some research project, when I was in undergraduate, I was participating in the lab work. And that time I was studying like magnetic tunnel junction, memory devices, how you can store the informations in using this magnetic tunnel junction film, these layer structures. So there we are using the foolproof transport measurement there. And always we are struggling to make interface nicely to have a big magnetic resistance effect, for example, to use in a memory devices to store the information. And then I learned this scanning tunnel microscope technique where you can see the atoms and molecules on the surface and study their properties directly. So then I was fascinated by this technique that, I want to study the systems using this technique, scanning tunnel microscope. So then always you're dealing with the atoms and molecules. So you use the quantum mechanics because you need to make it quantum tunneling to investigate the objects on the surface. So then, starting from my study, starting from this classical approach that to store the information in the memory devices, right? And then now slowly moving into this more smaller scale and then quantum limits that we can study the object using this quantum mechanics. And that time I didn't imagine that this quantum computation operation things are becoming very big hit like nowadays. So then I didn't think about this is very hot topic that I want to go on. I didn't imagine that someday we can make this quantum computation in reality, right? That because a classical limit, and then when you're using classical quantum computer and then classical computer and then quantum computer, it's really the amounts that you can calculate is really different scale, right? But I'm very happy that everyone is really excited about this quantum computation nowadays, and then it's more accessible for the public. I'm glad that. I think so. It's approaching. So then, now already companies producing commercial quantum computers. Still, there are more to go and then develop. Things are going on, but I think it's more accessible and then becoming more in real. So our challenge is that we are doing atoms and molecules on the surface, right? So to make it scalable, making bigger qubits platform, we need to use for example, molecular platform where you have a multi-spins that we can control to use as a qubit to do the quantum operation, quantum computation. So that would be our challenge to control this multi-qubit platform to be able to make it quantum operations more bigger scale. We can hopefully we can do more bigger quantum operations that we can compete with other quantum computer available in the field nowadays. I think so. This one, since we have this IBM quantum computer in Basque Country, that's very attractive that younger generation can access to use this quantum computer to do the calculations. And actually you can do the experiment using their qubits to do many different kind of operations. So I think that's very fascinating. And in our point of view, we are using SGM to be able to do these quantum operations as well, right? But then we can compare with what it comes out from this quantum computer. We compare with this and then what we can improve to make it more accessible. I think that's very fascinating and nice that we have this IBM quantum computer in Basque Country. I think this environment, scientific environment is really excellent. It's so nice that when I arrived and then when I look now, we scientific community grew a lot and we collaborated very actively. We meet the people every day. This active ongoing things, it's really nice environment that you can get an idea what we can do more things together to make a synergy. So I think I'm happy that I can work in Basque Country to do my science, my research.